वेलकम टू वी लर्न में आपका स्वागत है। सब्जेक्ट कॉर्पोरेट फाइनेंस, सेशन नंबर 10। टॉपिक कवर्ड इन दिस सेशन: IRR, इंटरनल रेट ऑफ रिटर्न, रिस्क एडजस्टेड डिस्काउंटिंग, फंडामेंटल प्रॉब्लम्स एस्टिमेटिंग द बीटा फैक्टर्स, अप्लाइंग APT, and now internal rate of return. Often managers base investment decisions on the IRR instead of NPV. ज़्यादातर ये देखा जाता है कि मोस्ट ऑफ मैनेजर्स जो है इंटरनल रेट ऑफ रिटर्न को क्राइटेरिया मान करके डिसीजन लेते हैं, नेट प्रेजेंट वैल्यू को डिसीजन में सम्मिलित नहीं करते। द रूल इज, अब ऐसा क्यों होता है? द रूल इज इफ IRR इज ग्रेटर देन द डिस्काउंट रेट, that is the cost of capital, then adopt the project. In many cases, this leads to the same investment decision as IRR is greater than the discount rate only if the NPV is positive. In other cases, this is not true. However, so to be safe, always use NPV or EBA calculation. IRR, NPV equal to minus I0 plus C1 upon 1 plus R plus C2 upon 1 plus R square plus C3 upon 1 plus R cube plus and so on CT upon 1 plus RT, where T is the time. If it is 0, then 0 equal to minus I0 plus C1 upon 1 plus IRR plus C2 upon 1 plus IRR square plus C3 upon 1 plus IRR cube plus CT upon 1 plus IRR की पावर T. Example, suppose investment cost rupees 100, first year's cash flow 150, discount rate 10%, then NPV equal to minus 100 plus 150 upon 1.1, which is equal to 36.36. That means 36.36 net present value आपकी आती है as per the using of discounting factor at the rate of 10%. It is positive and NPV को देख करके आप इस प्रोजेक्ट को एक्सेप्ट कर सकते हैं. बट इन IRR 0 equal to minus 100 plus 150 upon 1 plus IRR yield 50%. Since 50% is greater than 10%, so IRR greater than discount rate, it is optimal to adopt the project. Project that have the cash flow profile of a loan. Suppose investment cost rupees 150, next year's cash flow minus 100, discount rate equal to 10%. So NPV equal to 150 minus 100 upon 1.1, which is equal to 59.09. IRR 0 equal to 150 minus 100 upon 1 plus IRR, yield a negative IRR of 33.33%. But this project is clearly profitable even though IRR less than discount rate. IRR criterion is sensitive to the type of cash flow, assets or liability. IRR is not unique. In general, for T period project, there can be up to T different IRRs. IRR is not appropriate for mutually exclusive project, as small projects with high IRR and small NPV might then be preferred to large projects with low IRR and large NPV. IRR and mutually exclusive project, like discount rate 2%, project A has minus 10, minus 16, plus 30. Project B has minus 10, 2 and 11. So NPV of A equal to 3.149, calculated as previously using the formula. And NPV of project B equal to 2.534. IRR of project A equal to 10.79% and IRR of project B equal to 15.36%. Important point, Fisher separation, NPV definition. NPV with mutually exclusive project, either or. NPV with budget constraint, EBA and NPV, IRR, IRR pitfalls, test for next week. Important formulas, CAPM, experience return equal to risk-free plus risk adjustment, beta factors, covariance upon variance, factor models, return equal to risk-free plus risk adjustment, risk-free real investment equal to NPV rules, profitability index, EVA, IRR. Very important formulas, CAPM equal to RF plus beta, RM minus RF, where beta equal to covariance of RM and RF divided by variance of market risk. So factor model ER equal to RM plus beta 1 plus so on, where omega denotes risk-free premium. Net present value NPV equal to minus I0 plus C1 upon 1 plus R plus C2 upon 1 plus R square plus and so on CT upon 1 plus RT. Simple test questions. The risk-free return is 5% and the market index has an average return of 12%. What is the expected return of an assets with beta 1.5%? By using CAPM, you can easily calculate these problems. An investment cost rupees 1 lakh and offers a cash flow of 50,000 in a year first and 1,50,000 in year 2. The discount rate is 5%. What is the net present value of the investment? Should you adopt the investment? Explain. Third one, in a two-factor market, the factor betas of assets A are 1 and 0 and the factor betas of assets B are 0 and 1 respectively. The risk-free return is 5% and the average return on assets A and B are 10% and 15% respectively. What are the risk premia associated with factor 1 and 2? Investing in risky project, applying the CAPM and APT in the capital budgeting process, key problems, estimating the cost of capital for risky project. Number 1, applying CAPM and APT. Number 2, using comparison firms. Number 3, dividend discount models. Risk adjusted discounting, compute the expected future cash flow. We do not know exactly what we will get. ECT in period T. Compute the beta risk associated with this cash flows. The beta is covariance of the return with the market return over the variance of market return beta. Compute the expected market return of the cash flows. R equal to RF plus beta RM minus RF and discount equal to present value of C2 equal to ECT upon 1 plus R की power T. Fundamental problems estimating the beta factor. Betas for traded equity are easy to estimate. We simply regress equity return on the index return and possibly adjust to take into account estimation error, Bloomberg adjustment. Betas for project are much more difficult to estimate as there simply does not exist a trading history. Possible solution, use comparison firms. Firm B, imagine, has similar risk profile to the project in question. Using comparison firm, assets base need to be sufficiently similar to the planned investment. We need to adjust for leverage effect. The comparison firm may have debt. In general, it is only the equity beta of the comparison firm we can estimate, but we are really interested in the assets beta. The more the firm borrows, the higher the equity beta, even though the assets beta remains the same. Adjusting for the leverage, asset beta equal to value minus weighted sum of debt and equity beta. So beta A equal to D upon V into BD plus E upon V into VE, where V equal to D plus E. So beta E equal to BA plus D upon E, BA minus BD. Estimated equity beta equal the assets beta plus A leverage terms. Example, value assets 100, value debt 40 and value equity 60. So estimate equity beta 1.5, estimate debt beta 0. So 1.5 equal to beta plus 40 upon 60 into beta minus 0, implying beta equal to 1.5 upon 1 plus 40 upon 60, which is equal to 0.9. Implicating risk adjustment discounting with comparison firm, a project has the average beta of Church Kitchen, McDonald and Bendy. The equity beta of these three companies are 0.75, 1.00 and 1.08 respectively. The debt and equity values of these companies are 0.004 and 0.096 Church and Kitchen and 2300 and 7700 McDonald and 0.210 and 0.790 in Bendy's respectively. And the beta of the debt of these companies is assumed equal to 0. So the assets beta are Church Kitchen's 0.72, which is equal to 0.096 divided by 0.100 multiply 0.75. McDonald 0.77, which is equal to 7.7 upon 10 multiply 1. And Bendy's 0.85, which is equal to 0.75 upon 10 multiply 1.08. So average beta of project beta equal to 0.78 equal to 0.72 plus 0.77 plus 0.85 divided by 3. So risk-free rate 4% and market risk premium 8.4%. So cost of capital discount rate for the project is 0.1055, which is equal to 0.04 plus 0.78 multiply 0.084. Applying APT, the APT model estimate cost of capital by a factor model. So present value are given by present value equal to ECT upon 1 plus YT plus beta plus gamma, YT plus beta into gamma plus YT into gamma T का whole square. APT and CAPM versus alternative methods. A drawback with the APT and CAPM models is that they require a number of estimates: the risk-free rate of return, the beta factors, the market risk premium, and the factor risk premium. It can in some circumstances be better to work with simpler model. The dividend growth model is an alternative to the APT and CAPM. Dividend discount model, S0 equal to dividend plus S1 upon 1 plus R, S1 equal to dividend of second year plus S2 upon 1 plus R, etc. So S0 equal to dividend of first year upon 1 plus R plus dividend of second year upon 1 plus R square plus and so on, dividend of nth year upon 1 plus R plus dividend of 1 plus G upon 1 plus R square plus and so on. So S0 equal to dividend of 1 first year divided by R minus G. where R equal to G plus dividend upon S0, which is equal to growth in dividend plus dividend yield. What is comparison firm don't exist? In general, there is little we can do. However, if there exists firm where one division is similar to our project, we may be able to identify the relevant betas. For instance, if you want to estimate the beta of the network division of television companies, you can use the fact that these divisions play a varying role in generating the assets beta for these companies. Network division example: General Electric assets beta 0.99, 2.5% of value from network division and 75% from non-network division. So Viacom assets beta 0.78 and 50% of value from network division and 50% from non-network division. If non-network division are sufficiently similar, we know that beta equal to 0.25 beta network plus 0.75 beta non-network, which is equal to 0.99. Beta for non-network 0.5 beta network plus 0.5 beta non-network, which is equal to 0.78. So combined beta equal to 0.36. Pitfalls in using the comparison method: project betas not the same as firm betas. Mature projects generally lower beta than R&D project, etc. Growth opportunities are usually the source of high betas. Company values often significantly linked to future growth opportunities as opposed to current investments. Example: investment cost 1 lakh, annual running cost 5,000 for 5 years, expected revenue stream 50,000 for 5 years, beta risk of revenue stream 1.2, risk free return 5%, expected market return 12%. So the discount rate of running cost 5% as the cost can be assumed risk free, the discount rate of the revenue stream 5%. So 1.2, 12% minus 5%, which is equal to 13.4%. Present value equal to minus 5, 1.05 की पावर 1, minus 5, 1.05 के स्क्वायर, minus 5, 1.05 क्यूब, minus 5, 1.054, minus 5, 1.05 की पावर 5, plus 50, 1.134 की पावर 1, plus 50, 1.134 की पावर 2, plus 50, 1.134 की पावर 3, plus 50 into 1.134 की पावर 4, plus 50 into 1.134 की पावर 5, which is equal to minus 21.65 plus 174.16, which is equal to 152.51. So NPV equal to minus 100 plus 152.51, which is equal to 52.51, which is greater than 0. Therefore, adopt the project. A firm with equity currently valued at 1 lakh and outstanding debt worth 50,000 hold 25% cash and 75% of risky assets on its balance sheet. The equity beta is 1.5. You consider investing in a project very similar to the risky assets owed by this firm. The risk-free rate is 5% and the expected return on the market is 12%. Work out the project beta and the cost of capital of your project. Assume debt beta is very close to 0 and also assume that the cash balance has a beta close to 0. So the total assets beta 1.5 divided by 1 plus 50 upon 100, which is equal to 1. Total assets beta equal to 0.25 multiply 0 plus 0.75 multiply beta. So beta equal to 1 upon 0.75, which is equal to 1.33. Cost of capital equal to 5% plus 1.33, 12% minus 5%, which is equal to 14.33%. Taxes and financing. Irrelevancy in the absence of transaction cost and taxes, Modi, Gilani, Miller. Financing choice is not neutral to taxation. Level corporate versus private tax rate. Timing, dividends can be deferred, whereas interest payment on debt cannot be. And now, do it yourself. What do you mean by APT and CAPM? What is IRR? How it is calculated? And that's it from session number 10. Thank you.